We're here with Aiden from Oberkamper and Associates. Aiden is our surveyor today. We've been on this piece of land for a couple weeks now. We just cleared a bunch of poison oak out here because we knew Aiden was going to be right at the property line surveying this, well, all the property lines, but this in particular had a ton of poison oak and we didn't want to destroy him with that. So we had about a truckload and a half or maybe 2 truckloads of poison oak taken out so that he can get his equipment in here, and thought we'd just have a chat and see what it is you do, and like what is all this cool equipment, and how do you even figure out where we are in space in the world, and how, you know, just roughly how's it work?
Yeah, okay. So what we're using here is a total station. It's an EDM, we call it. It just measures infrared, and basically, some people like to call it, it's a fancy tape measure. Right, that's all it does. It measures angles and distances all electronically. So, and that allows us to do a coordinate geometry. Short, it's also called COGO. Using coordinate geometry, angles, and distances, then we can compute points. We can stake out. We could do topographic surveys. We can measure. So,
and you're doing all that for us today, right? You're giving us a boundary survey. And then a topo, which shows us all those lines that help describe how the topography works. And there's a lot of topography here, so we really need to understand how the land is sloping so we can figure out the driveway and where the house sits and all that. And then, so what's this piece of equipment?
So this is a data collector here. This rod and prism, this is how we measure, right? The total station sends a laser, an infrared laser, and it's basically a sine wave, and then it bounces here and comes back and then measures how many, the sine, how many waves, and that's how it calculates a really precise distance.
How accurate is it?
I'm usually within 1,000, sometimes 0, like
thousandth of an inch?
Thousandth of a foot.
Thousandth of a foot.
So 0.002.
Okay.
But there's always parts per million errors.
Sure.
So, safely you could probably say 100th of a foot at any given moment.
And it used to be in the old days you'd have 2 guys.
Yeah.
But you're out here alone today.
I'm out here alone today. That's because the technology, leads us to be able to do that.
I noticed this thing just swivels around on its own and finds you. You're walking around with this.
Yep.
And this thing is just looking for you, right? Is that kind of what's happening?
Yep. We call it a robot. It's robotic. And I can control the robot from this.
Oh.
And I could tell it, turn this way.
I'm over here.
And search, it'll search. It could find me.
So this land's been surveyed before. The county's told us we want a new survey from a licensed land surveyor who's alive. The people who surveyed it before are deceased, and so we don't actually have like a live stamp of a licensed surveyor, so we had to survey it again. But you're out there, in a way, looking for monuments or pipes that are already in the ground. Is that right?
Correct.
And so you've got a metal detector to help you find that stuff?
Yep, we got a metal detector. That's correct.
And so I'm guessing you kind of like use your devices to get close, and then you go and it says, "Oh, it's roughly over here," and you go look for it.
So that's one of the hardest part about finding boundaries is sometimes you have to find one point, right? And if you can't find at least one point, then you're pretty much dead in the water. So nowadays we have GPS. We can use GPS when there's when it's open.
Right.
This particular site, it was pretty hard. There's a lot of trees, so you can't really do GPS very well. Now on a big street, on the subdivisions, it's a lot easier because we can actually use satellite imagery, aerial imagery, and we could pinpoint where the points might be using the satellite, the aerial imagery. So it gets us sometimes we're within a foot and we can just dial up the GPS and we can just say, hey, you know, this is roughly where it is.
Right.
But in this case, since there's so much tree cover and we don't have enough satellites, we have to, sometimes they call it dead reckoning, and where you just go out and try to, you know, use your best instincts and try to follow the surveyor and try to find at least one point.
And you found a couple already, right?
Yeah, there was 2 already, so that really helped us. And
now we saw one over there in that corner, and we saw 2 down here.
Yeah.
Why are there 2 over there?
for whatever reason, there's an angle point, so there's a small angle point, and so the surveyor decided to set, you know, a monument on that angle point. The map didn't show that there was a monument there, but we found one there.
So one of them's actual. Does that mean that one of them is actually the property corner, and one of them is sort of a waypoint-ish?
It's an angle point. So if you have a straight line, and then you have another straight line, he put one on the angle point.
Oh, I see.
And then there's one on the corner here.
And that's just because this side is sort of faceted. This side of the property isn't a straight line.
Correct. Yeah. This has angle points. The front's got a small angle point.
This side's pretty straight all the way, right?
This side, yep, it's pretty straight. Yep, correct.
Okay. Thanks for coming out and doing this for us. I mean, we need the work done so that I can get in and do my 3D modeling. Well, one of the other things that Aiden's doing is he's actually locating the points of these adjacent houses. So we've talked about this house that's lower on the property and the house that's higher on the property, and we want to be sensitive to our neighbors and make sure that our design doesn't overly impact them. Of course, we're going to do something here, and it's not the same as having a blank site, so people can get a little sensitive to that. But we need to be careful to kind of find that sweet spot where we're doing what we want to do and we're not upsetting anyone else too much. And so what I asked him to do is to locate points on these roof lines of these adjacent houses so that I can put them in the 3D model, have them rotated properly in space, have them located vertically properly in space. And that way, when we put our own 3D model in there, we'll be able to see what are the view impacts of our house on their house, and what are we going to see from our house when we look over their house, and how does our landscaping need to be? And we'll sort of learn a lot about the sort of 3D complexities of this site from shooting these 2 buildings. And I'm guessing that's a little different because you can't go and take that thing and walk up to their building, right?
Another great point. So we have something that's called reflectorless mode, and reflectorless mode allows us to shoot the laser, and the laser knows that since there's no sine wave coming back, it knows that it hit a hard surface, and it could still locate based on what I'm assuming doesn't come back to create a distance.
And is that like a little less accurate, or
no, it's just
different,
as accurate as the guy could put on the point. It's pretty accurate.
So you're going to use the total station to do that too?
Correct.
You just set it in a different mode.
Yep.
Awesome.
Correct.
Okay. Great. Well, thanks, Aiden. It's been a pleasure.
No problem.
Awesome to have you out here. Thanks for talking to us, and looking forward to seeing your map. What we're going to ask Aiden for, and maybe, I don't know if it's you or my guess is some CAD guys in the office take all the data out of here and then translate it into a map. Is that someone else does that work? Right?
I do that too.
Oh, you do?
Yep.
Okay.
Currently, yep.
So what we're going to ask Aiden for is a couple things. I'm going to want a flattened topo map, and what that means is when the data comes out of here, they interpolate the points to get the contour lines, but it's typically in 3D, so all those lines are actually kind of in 3D space. When I'm doing my CAD work, I like it flattened, and I also ask for a graphic scale on my topo map, because then I can put it in my iPad, and I can tell my iPad from here to here is 50 feet, and it scales it for me automatically, and now I can sketch on top of it. So topo doesn't always come with a graphic scale, but I find that helpful just in this kind of digital translation between AutoCAD and my SketchUp 3D model and my iPad. I can sort of manipulate these different versions of this map in different ways. So we'll get a flattened topo, we'll get a unflattened topo, and the flattened one will hopefully have a graphic scale on it so we can sketch and kind of play around a little bit more. And then we'll see what that looks like, but we're expecting that probably a couple of weeks or so. We'll get that from these guys and we'll go from there.
Definitely.
Thanks again, Aiden.
No problem.
Okay. So it gives you a graphic layout of the points. And it's basically a plan. Is it like a 2D plan that's showing you right now?
Yeah, so I have to code. By using the proper codes, I can tell the software to string a line between certain points. And so as I go along here, I can draft it, basically draft these points, draft these line work in the field, so I could bring it back into the office, and the line work is just boom, right there.
That's crazy. That's super cool. So it helps you actually, when you get back to the office, it helps you sort of interpret the information better too. So instead of looking at a bunch of random points that you have to kind of reconnect in your head in some way, you sort of have almost notes as to like, oh, what does this all mean really, right?
Exactly, yeah. Instead of connecting points together, all the points are already connected together when we get back to the office.
That's super cool.